hasn't officially started yet, so I don't feel dumb. Drag the window, drag the keynote window over. Anybody know how to do this? It always just like puts it all in the same window for me. I've never had it off to the side. I have to switch it so that this is your main screen here. How would I do such a thing?
Go to your preferences, display preferences.
Awesome. That is so cool.
Now just present it.
Where the heck is my mouse? There it is. Oh, there it is. Sneaky little guy. Oh, it's so small. Whatever.
You can change the resolution of the other display.
I am really liking how smart you guys are. Displays. And then, for some reason, it's hidden. If we make this guy 7 function. I'm pretty sure that's switched on this one. I swear the talk will not be as bad as the pre-talks is set up.
So if you change that, change that to one of the small ones.
Ooh. That's
Yeah.
awesome. That was like crowdsourced. All right. Yeah, we'll just start. They'll come say if they want to. So I'm going to talk about machine learning in JavaScript. On the schedule it says machine learning in the browser. There's always a couple of different talks. There's the talk you say you're going to give, and then the talk that you actually give, and the talk that people hear. And my talk kind of changed a little bit while I was preparing it. So we'll talk about some browser stuff, but it'll be a lot of other stuff as well. But it will all be in JavaScript. Yes, sir. Maybe. Do I have to press it? Record. It's going. Oh, there's going to be 20 minutes of me like muttering to myself. Okay, good. So a little bit about me. My name is Jamison Dance. I'm a software developer at ITV. ITV is a JavaScript-based startup. They do second screen technology stuff. So if you're watching TV, you can like pull up an app on your iPhone or your computer to get more information. It's all JavaScript, front end, back end. So we do Node.js, all kinds of buzzwords. That's cool. It's a great place to work if you guys are looking for work and if you really enjoy working with JavaScript. We do lots of wacky and kind of we kind of push the limits of what you do in JavaScript, and this is an example of something weird in JavaScript. So if you guys like this kind of stuff, come talk to us about ITV. I'm Jurgensen on Twitter, JamisonDance.com. If you want to read stuff I blog about. And when people hear about machine learning, they think like PhDs, you know, like you have to be really smart to know about this stuff. So what are my qualifications? Am I really smart? No. I'm not really smart. I'm just curious, right? I did an undergraduate in CS, but I don't have like an advanced degree or anything. But I just thought this stuff was cool, and I've kind of played with it a little bit. So you don't have to be like a scientist, right? I mean, you don't have to be a genius to use this stuff. So I used to work at SpotRF. Jacob works there right now. So does AJ. Hola, hombre. And we did some secret machine learning stuff that he would beat me up if I talked about. And then I've also done a lot of machine learning stuff on StackOverflow.com, just playing with it to do some personal projects. So that's my experience with it. A couple of years doing it. What is machine learning? So what do you guys think of when you hear the words machine learning?
Detects patterns, compares against the database.
It's a really good answer.
Terminator 2.
You.
Oh my gosh, you did it. Oh.
Any other things you think of?
Machine language.
Machine language? Okay.
Yeah.
Anything else? Does anyone think of math? But, so Jeff gave a great definition. I'm going to read a definition by another guy. He calls it making computers modify or adapt their actions so these actions get more accurate. This is a guy named Stephen Marsland. He's just a machine learning researcher. He's wrote a couple of textbooks. He's a good guy in the field. So it's basically training computers, right? Teaching computers to recognize patterns. And you can kind of compare it to training a dog, right? Dogs don't come into the world knowing how to like fetch or roll over, play dead or anything. And how do you train a dog? Has anybody trained a dog before? You hear
repetition.
Yeah, repetition. So what do you do if they, so you kind of make them do something, what do you do if they get it right?
Lecture. Positive feedback.
And then what do you do if they get it wrong?
Negative feedback.
Yeah, so you're kind of reinforcing the things they do right and discouraging things that they do wrong. And it's the same idea with computers, with machine learning, right? So you try and get a computer to do a task. If they get it right, you reinforce that. If they get it wrong, you kind of unreinforce that. I don't know what that word is. Anyways, does that make sense?
Just don't ask it to play dead.
Yes. I do that on accident a lot. So why do you guys care about machine learning? What can you do with it? Has anybody seen the Google self-driving car stuff? That is like 99% machine learning. All the algorithms to decide where to turn and stuff, that wouldn't be possible without machine learning. Can you imagine writing a program that would just like know how to drive? Like you have to write all the code that tells it how to drive? That would be kind of scary, right? So machine learning is for tackling these problems that are really complex and have all these patterns that would just be intractable to encode through writing an actual program. Another reason why you care is we have an avalanche of data. This is kind of like played out already, I guess. But there's like Twitter, Google Plus, probably nobody uses it, but like Facebook, I don't know, all kinds of different data streams coming in, right? And it can get a little overwhelming. How do you tell what's good? How do you tell what's interesting? Machine learning is tackling a lot of these problems. You guys heard of Prismatic? Has anybody not heard of Prismatic? Okay, I'll show it really quickly. It's actually really sweet. And they do lots of machine learning to figure this out. Mouse. Oops. Yeah, that looks a little more professional. Alright, so Prismatic is a web app that takes your social network, right? So you can hook up Twitter to it. I think you can hook up Facebook to it. And it also takes preferences that you express through like liking or disliking stuff that they show you, and it builds a model of stuff that is interesting to you. So if lots of the people that you follow tweet about something, then it'll pop up here. If you have shown that you like programming or Ruby or game development, not Java, and stuff like that will show up here, right? So you can tell, I don't know, some of the things. Very sad moment. That I think are interesting, and it actually does a really good job. And this is all done through machine learning. So back to I think the main takeaway is that machine learning helps us get insight out of data. Richard Feynman was a famous computer scientist, well, more of a mathematician, but he said the purpose of computing is insight, not numbers. So we have all this data, but it doesn't really tell us anything. Machine learning can help us get insight out of it. And then, why do this in JavaScript, right? There's all kinds of machine learning stuff in MATLAB and R and C and all these other languages. Have you guys ever heard of Apple's Law?
Whatever can be done in JavaScript will be done.
Exactly. So it's like because it's there, right? Why did you climb that mountain? Because it's there. Someone wanted to climb it. And also because I think it'd be cool. Puppies are cool too. I don't really know what the connection is there. It's just like a fun thing to do. So we're going to talk about a machine learning algorithm called naive Bayes. And since some of you guys might really not want to talk about math and get kind of scared by it, we're also going to throw in some puppies in case you get overwhelmed. But it's let's see. It's important to know kind of the background of the things that you're using if you want to do machine learning. So you can just use it as a black box. There are programs you can download that you can just put your data in, click a button, it'll do some learning, and it'll spit the data out, right? But you have no idea what's going on. You can't. It's really rare that a real interesting problem will allow you to just plug in some data into a pre-existing solution. If this is all a black box to you, then it's really hard to kind of manipulate the data into a format that the algorithm needs, or figure out what is important to learn from. So this is all about making it a little bit less of a black box. Because I could just show you I could just show you that it works, and that'd be like cool, and you could go off and try to use it. But if you ran into problems, you'd be really stuck. So it's really important to kind of peel away a little bit of the mystery about how this stuff works. So this is a really simple machine learning algorithm that is really widely used in spam coding. So here's an email. I'm trying to become a spammer. This is the one I wrote. I heard semicolons are really popular in JavaScript right now, so I'm trying to sell semicolons to people. So I'm setting out this spam. If you were trying to filter spam, what is a way that you could think of to do this? Instance of keywords.
Keywords.
So what do you mean keywords?
Illustrious, graciously, madame.
Accumulation of keywords.
So like count up all the keywords that seem like they're really spammy.
Yes. And like the email addresses too.
Yeah, that's a really good idea. I'm pretty sure.
Even the phrase of send a money order.
Yeah, exactly. So you could do not just keywords, you could do n-grams, right? So multiple words together.
IP address, country of origin.
Yeah. Whether they say they're a prince or not. Yeah, so you can think of all these things to put it together. And naive Bayes kind of takes this idea and it builds off the frequency thing that you guys hit upon. So one idea that you guys talked about was you count up all the words that are like in the spam category. You count up all the words that are in the not spam category. And then when you get a new email, you just say, okay, here are all the words in the email. Are these words spammy or not spammy? It's kind of the main idea behind naive Bayes. There's a little bit more subtlety to it, though. So this is called a Bayesian Network. It basically just shows how different things influence other things. So we're going to call this the class. The class is like spam or not spam. That's a machine learning term. So if something is a spam email, we say that its class is spam. If it's not spam, we say its class is not spam. Right? And we say that the class causes the words to happen. So if it's spam, the class will make these spammy words appear in the document. Does that make sense? And if the class is not spam, then these words will be like not spam words. But the class is the thing that's causing those words to appear.
It sounds reversed to me. Could you explain? I don't get it. Sorry.
Yeah, so it sounds kind of counterintuitive because that's not how we often think of things. But you can think of it as like you just decide ahead of time if you're going to write a spam email or a not spam email. And then so all you know is it's going to be spam. And then you know these different probabilities of words that are going to appear if it's spam. So you just pick words that are more probable to appear if it's spam. So it's like the class is causing the words to appear. Does that make sense?
Yeah, could I throw in an example?
Yeah, that'd be,
So-
and if anyone, I mean, I'm not an expert, so if anyone knows more stuff.
So the way I always think about it is it's trying to build a model of the spammer. So you can think of the spammer up there, and you're trying to build a model in your computer of what the spammer is thinking in their head when they're typing out, "Hello, illustrious madam, would you like to buy some Viagra?" And so,
Hey,
semicolon, sorry. So you're trying to build the model in the computer of what the spammer would be thinking. And the spammer is generating the words, so your model is generating the words. I don't know if that
Go on.
makes it better.
we can talk after too if
So
you're.
then you did count up the words to see if it fits one class or the other class.
Yeah, so that's the thing. So this is just clarifying this is spam or not spam, and this causes the words to appear. But so when we look at an email, all we see are these words, right? We don't see whether it's spam or not spam. So we have to somehow look at the words and figure out which class it came from. So that's what these counts are for. So we say there's only 4 words that can ever possibly be in emails in this example. Not very realistic, but that's okay. So for each word, you count up how many times it occurs when the label is spam, when the class is spam, how many times it occurs when it's not spam. So for word 1, it occurs 50 times when it's spam, 45 times when it's not spam. For word 2, and then so on. We have all these counts, right? And how do you guys feel about puppies? That'd be pretty good. It's a little intense. So it's a puppy break. Oh, so cute. Okay, cool. All right, so you end up with these probabilities of words appearing depending on whether it's spam or not. And now it's a little bit, now it's time to formalize it a little bit with something called Bayes' theorem. This could be the most important equation ever, maybe? I don't know. I'm not ready to come out and say it is, but it might be.
It looks like the equation itself would define whether or not it's the most important if we know what A and B are.
Yeah.
Put the formula in as P, right?
That's really meta. I like that. So this is Bayes' theorem. You use it to predict probabilities of things happening. So the P stands for probability, and we'll fill in some English words here, right? So we're saying the probability of the class, so probability of it being either spam or not spam, given some email contents. The little pipe thing means given. So you know the email, you don't know the class, and you're getting the probability of it. Is the probability of the email given the class times the probability of the class divided by the probability of the email. So first of all, what does this mean, the probability of the class? This is just what you think the probability of getting spam or not spam is before you see anything about the data. So this is called your prior. If you think that 99% of email is spam, then the probability that the class is spam would be 0.99. The probability that it's not spam will be 0.01. Does that make sense? And that's why that's one of the reasons this formula is cool, because you're not just counting up how often things appear, you're also taking into account stuff you already know about it. So, I mean...
And even if you had no background information, you could start with 0.5
yeah.
and then just iterate.
Yep, yeah, exactly. That's perfect. That's exactly what you do in lots of cases. And you'll update this is called the prior, so you'll update your prior as you iterate over it. This is called the likelihood. So if an email is a spammy email, then how likely are we to see this sequence of words? And it sounds kind of weird to think about it that way, but you can actually calculate it pretty easily, and we'll talk about how you can do that.
I'm a little confused right now. With the P email down there, the probability that's an email is like 1, right?
So this is the probability, yeah, I should have been more clear. This is the probability that the contents of this email. This is the probability of receiving these particular words in the email.
In any email.
Yeah.
You're given a certain
So we can do like probability, if it makes more sense, of like word 1 and word 2 and word 3, right? Okay. So this is the contents of the email, not the event of getting the email itself.
Isn't that like 1 in a bajillion?
It is.
Well, you define your
so that's why this is called the normalizer, right? Because if this is a really small probability, these probabilities up here are going to be super duper small, so you divide by a really small number to give you like a reasonable result. That's an actual probability.
Okay.
Yeah.
You define your data set to include only 4 words, right?
Yep. Yeah. And in real data sets, you have to have tons and tons of data to train on, so that you'll have numbers that make sense for these probabilities. Because if you only have like 5 emails and you try and build a classifier, then you're going to have tons of words coming in from new emails that you've never seen before, and you won't know anything about the probability of having this word in an email and that word in an email. So yeah, we'll talk about that a little bit more too.
Just a comment, like
yeah.
When I was studying Bayes' theorem, one thing I was kind of funny thinking through was that what's the probability of me being late for work if I wake up late, and what's the probability of having woken up late if I'm late for work? And I was like, those are different? I'm like, yeah, and it just...
Yeah, it's pretty sweet, huh? So your agreement is the most important theorem ever created.
People philosophize over it like crazy.
Oh, they do.
There's been tons of philosophical disagreement over that theorem with huge conferences.
Okay, this is an aside, but if you ask a statistician whether they're a frequentist or a Bayesian
it's a religious question.
Yeah, they will either, someone will get burned at the stake. They battle against each other.
You're a Bayesian?
I'm not a statistician, but if I was, I'd be a Bayesian.
Okay.
But
Anybody who uses
about
the word
statistics.
frequentist is already a Bayesian.
See, you're already in dangerous territory there. Charges are coming. Aren't you a math professor?
Yeah, I'm
Okay.
also a Bayesian.
All right. So I just got scared. All right. So we'll go through this just a little more to make sure it's clear. So the class again is either going to be spam or not spam. So this is the probability that it's spam or probability that it's not spam, given that you've seen these words in an email. Up here, given these words in the email. So what we think the probability of spam or not spam is, that's the prior. And the way you actually use this in real life is you try each one. So you get a new email, you say, okay, let's assume that this email is spam. What is the probability that this email is spam, given that we have these words in it? And you'll get some number back. And then you say, okay, well, assume it's not spam. And what's the probability of getting this email if it's not spam? And you get some other number back. And then what do you think you would do to call it spam or not spam?
Choose the bigger one.
Yeah, you just pick the biggest one, right? Oh yeah, it's right there. Come on.
You know, you can make that a little clearer if you don't do spam and not spam, but you have 3, 4, 5 different things to classify, rather than just a yes or no decision. Now with spam, it's yes or no.
Yeah, well, it could be like spam I love, spam I don't like.
Well, maybe we could classify it as like Nigerian prince.
Okay,
versus-
you could do like recruiter emails, and then the rest is spam or something, right? Yeah, so that's a very good point. You can have lots of different labels that you're checking here.
So could you use it to like distinguish between Nigerian print and the artist formerly known as print?
So you could, depending on how complex you want to make your model. So a couple observations about this. These are the same number in both cases, right? The probability of receiving these words in an email is the same whether you're calling it spam or not spam. So you can just drop that number and get it won't be equal to, it'll be an approximation, but the relationship between the two will be the same. So it simplifies the equation a lot.
Well, you can always normalize it later if you want.
Yeah, exactly. Yeah. So it's one less thing you have to calculate, and that thing is actually kind of hard to calculate. So that helps us a lot to ignore that. And then another case, if you assume that the priors are the same, you can drop that too. That's not always a good assumption, but it can. You can just say the probability of spam, non-spam are the same, and it simplifies things some more.
Like 50-50 or?
Yeah.
Okay.
Yep. What were you going to say?
If you categorize your entire learning data set as either spam or not spam, does it guarantee that your probabilities will always sum to 100%?
If you do this one, it will. Yeah.
Okay, thank you.
Yep. So if you see these are the same, you drop these, and the equation is getting simpler, but how the heck do we calculate this? Right? I mean, you can kind of think of how this sort of makes sense. So if we know the contents of the email, obviously it's going to tell us something about whether it's spam or not spam. But how does knowing whether it's spam or not spam tell us anything about the contents of the email? And through the magic of probability theory and assuming that all the words in the document are independent, you get this equation. So that's a really important assumption. When you're writing an email, when you're communicating words, the words that you pick depend on the words that have come before, right? If you're writing an email about a rock concert, then you will have words about rock and roll, right? You won't necessarily have words about like chemical reactions. Maybe if it's like making some meth at the rock concert, I don't know. But so words are not independent in documents that we create, right? If you know some words, that changes the probabilities of other words appearing. In naive Bayes, the reason it's called naive is because you just assume that knowing one word tells you nothing at all about the words that are coming before or after. So that's called independent. So knowing one word doesn't tell you anything about the probabilities of the other words. That sounds like a really bad assumption because it's so different from how English and languages are. But in practice, it actually works really well, and it makes it really easy, which is probably the main reason that people do it. So if you assume that they're independent, you have this list of words. I'll change this again because it was confusing. This just says email. Word 1. So the probability of these words occurring given spam. This is the chain rule? What is the rule called? What's the rule called that lets you...
No, it's just independence. Right?
Just independence? Okay, yeah, just the definition of independent probabilities. Lets you split it up on all the words. So you can, remember how we had those counts? We'll go back to them to make it simpler. And we'll see the puppies again, because it's been a lot of math. All right, so remember how we have these counts? So if it's spam, this word appears 4 times. If it's not spam, it appears 55 times. That will give us the probability of a word appearing given spam or not spam, right? So it'll be, so we know all those. So we can calculate all these, and we just multiply them together, and we get some probability, and we do it again for not spam, we get some other probability, pick the largest one. Emergency kids, because that was also a lot of math. Oh, so cute. There's, yeah, the kid in this,
Hand puncher.
a really good Far Cry player. So there's a Twitter account called Emergency Puppies. I really recommend it. It's really good. That's where these came from. Oh, so cute. Oh, so adorable. All right. Cool. So we talked a little bit about how naive Bayes works. If you haven't just glazed over completely, hopefully you have a little bit of an understanding. It's basically taking the idea of counting up how often things occur based on the different labels, and you use that to calculate probabilities of labels for new things coming up. So how do you use this in the wild? What's an example of where you could use this? Here's an example I came up with. Everybody hates Hacker News. Do you guys know what Hacker News is?
I love Hacker News.
Well, you're not cool enough because it's really cool to hate Hacker News.
Maybe we could discern whether that's truth or not through a Bayesian filter.
Maybe we could. But I don't know. Hacker News is a news aggregation website for like technology and entrepreneurship in general. And it's been around for a long time, and like every online community, after a long time people start complaining about how all the new people have ruined it and how horrible it is and stuff. And I don't know, I feel like there's a little bit of truth to that. It has gone downhill a little bit. You can see all these angry tweets by people about Hacker News' startup fan fiction. So Hacker News loves to talk about like quant programmers and the investment industry and stuff, and Hacker News denizens are so cynical, and Hacker News would be better without the comments, and Hacker News is just hype, and when people read stuff on it, it's already played out, and it's dumb. And so here's an example of the front page of Hacker News, and there's a couple interesting things, but there's all this crap on it. Like, I don't care about the Yahoo CEO having lied about having a CES degree. That's like drama. I don't care about drama. I just want to learn cool stuff. So crap, 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 crap. Crap! Mostly crap. But it's like, you know, you guys know TMZ. It's like this gossip magazine. It's like TMZ for hackers. Like, oh, some guy's mean to me. Real sucks. You know, it's so cool. Like all this drama. And I don't care about the drama. I just want to see the cool stuff. Like, there's a couple cool things on here, right? Machine learning in Python, that's cool. Text editing on the iPad, to me that's cool. Ruby Motion, did you guys see that?
Yeah.
That's sweet. It's somebody wrote, is it an IDE? Or it's like an IDE and a bridge and all kinds of stuff for writing iOS apps in Ruby, right? Do you?
Yeah, I think it's just a bridge, right? Where you can just write your stuff in Ruby.
Because there's already MapRuby, so is it like the iOS version of MapRuby, basically?
No idea.
Or is it a transpiler or is it?
I don't know.
Okay.
That's tangent, but it's cool.
It's a tangent.
Either way, I think it's cool. There's a couple other cool things. So there's some good stuff on here. It's not all crap. So what we would like to do is automatically find the good stuff, right? Find stuff that I think is interesting. So I don't have to go through people whining about famous people and the drama and all that stuff. So step 1, gather the data. How would you gather data from Hacker News if you wanted to build up a model? So you can scrape. They are really vigilant about blocking people, though.
Well, you can just have a widget, right? You just click the widget and have it scrape the data every time you.
You can do that. and that was a smarter idea than what I did. I used something called JSDOM. And I scraped this site called Hacker News Archive, which just pulls the front page, not the front page, the top 10 posts on Hacker News, like once a day, every day, and it goes back to like 3 years or something. So I scraped it with JSDOM, and I want to show JSDOM.
That's semicolons.
Huh?
Semicolons.
Yeah, ITV doesn't like semicolons, but AJ likes semicolons, and we use CoffeeScript at ITV, so I don't have to convert to their weird semicolons style. Anyways, so this is a Node.js program that uses JSDOM to scrape the Hacker News archive page, right? So we require JSDOM. Do you guys know Node.js? Are you familiar with it? If you're not at all, it's just, you can think of it as server-side JavaScript. So this will be run on a server or on a, not in the browser basically. So we require JSDOM, and we call this env function and give it a bunch of stuff. So this is the URL of the page that you want to load. You can give it actual HTML text as well, so it could be like tags in here and stuff too if you want to parse that. You give it some scripts that you optionally want to load once the page is loaded. We want to load jQuery so we can manipulate it and such. And you give it this done function that gets called once the page is loaded with these scripts in it. So this function will just store the little jQuery $sign that is assigned to the window object, so we can use our familiar syntax. And then it'll just pull in one of the links from HNDaily and just print out the text of it. Does that make sense? So JSDOM is it's an implementation of the DOM in JavaScript. I don't know if I said that, but it's pretty sweet. So if we go to terminal, clear that node, we run JSDOM example, assuming the Wi-Fi works well. Awesome. So it pulled one of the links from one of the pages from last month, right? And that's the title of one of the links. And yeah, so you can imagine doing that to all these different things, to scrape the titles and the URLs and the comments and stuff from all the different Hacker News postings. So that's what we did. And then you want some way to store it. I just set out to store it in Mongoose because why not? Use Mongoose to work. You can do it in just a flat file too. But Mongoose is a MongoDB, getting all the buzzwords in. The MongoDB
driver for Node.
Yep. And I have an example of that as well.
Side note, tangent, how do you open and close nerd tree like that?
Just nerd tree, bottom. And then, I was doing it the slow way too. You could actually just do nerd tree and, nope, you can't. Okay. You'd have to actually close it, which is Q while you're in the nerd tree.
Nerd tree toggle. Nerd tree toggle.
Does that work? Dude, I'm always down for learning new stuff.
It seems like that's longer in terms of...
Well, you could just bind it.
Well, you could do colon Q, right?
You could, but it wouldn't be as cool as Peter and...
I do comma NT.
I don't know what the heck that means, but that's awesome.
Oh, yeah. Okay, anyways, distractions, I'm sorry, tangents all around. So, yeah, Mongoose is, like somebody said, a database driver for MongoDB for Node.js. The way Mongoose works is you define schemas. So, MongoDB is like a document storage database. You just put like JSON in it, basically. It's not tables and rows and stuff like that. But with Mongoose, you can formalize it a little bit by defining these schemas. So we're creating a new schema that has a title, a URL, and an author string. And then we're connecting to the database. This thing gets, this says, put the schema in the database and give me back a model to create new instances of the schema. And then here we're actually creating a new right? And then we'll save it, just log it once we do it, and then close the connection, because otherwise it hangs around forever. I don't know the hard way. scrape the DOM. We can pull all our data into the MongoDB. And then just as an aside, with most machine learning projects and data mining projects, the like cool part is the machine learning, and that's like 10% of it, right? Most of it is like scraping stuff and munging data and figuring out some of these weird format that they have decided to like limit you to like 5 requests every week, or I don't know. There's all kinds of little hurdles that you have to jump through. So it's really important to know the algorithms, but most of the work will actually be in just doing these steps where you're prepping data and getting in stuff. So, and then we have to train our model. And the thing I use to train the model is there's a couple different naive Bayes classifiers out there. The natural project from Node.js, it's a natural language processing thing. It has a naive Bayes classifier. There's one called, I think it's just classifier.js by the lady that wrote Brain.js. And then I wrote one called Credulous because there were a couple things about the other ones I didn't like very much. And it's more fun to write it yourself. And that's like what all the Node units do, right? They rewrite everything from scratch ever. Yeah. But, so I wrote a naive Bayes classifier called Credulous. Just as a review, we have our class. And in this case, instead of spam and not spam, it's going to be, do I like this thing or do I not like it? And then we have a bunch of words that we'll see from the title. And then the other things that I chose to train on were just the username of the guy who posted it, and then the host name. So I hate TechCrunch, and Hacker News loves TechCrunch, and I don't ever want to read anything by them. So I wanted to appear in the model that, hey, he really hates stuff with the host name of TechCrunch, so we won't recommend stuff like that to him. And then maybe there's some users that I really think are interesting, or some that I don't think are interesting, so I thought that'd be cool. And then, yeah, just the title of the post. I didn't put in the votes or the comments, because those are time dependent, right? If you see something when it first gets submitted, then it won't have any votes. Well, it'll have one, and it won't have any comments. And if you see it much later, it could have a bunch of votes. But we want to know about stuff when it first appears. So the votes could tell you a lot, but they also could weight it. Maybe the things that I think are the most interesting aren't the things that the rest of Hacker News think are the most interesting. You could also include them in it. I mean, you just try and see, right? That's like the main thing. And then I made some beautiful programmer UI, Node.js, to rate posts. So we'll go over here to project, go to command line rater. We'll make it bigger. So what this does is it just pulls a random post that I haven't rated yet out of the database, shows me the title, URL, and the user, and it asks me to rate it. And I do this like 8,000 times. Oh, shoot. That doesn't happen most of the other thousands of times. Should I live code, or should I just say it worked and leave it at that? It's really scary to code in front of people.
Live code, live code.
Oh gosh.
Live code, live code, live code, live code.
All right. Screw it. We'll do it live. Oh, this is going to be a huge pain though, because I'm going to have to, can't put it on my other screen or it won't be live coding. I'll at least leave it small. 94.
What library did you say you were using for learning?
It's called Credulous. Like, naive is like credulous. It's really dumb. But, yeah. But there are also a couple other ones that might not throw errors on you when you're trying to demo in front of people like this.
Everything throws errors when you try to demo. That is the rule of demos.
Yeah.
So, when you get a chance, just explain a little bit how those libraries work.
Yes, I will show that. So, we can do that right now, actually. So this is a wrapper around Credulous, but the way Credulous works is you just make a new model by calling the constructor, and you give it an options object. Right now, the only options it takes are the possible labels. And then this thing called data length, which is a horrible name. I couldn't think of a better name. means how many different kinds of things are we looking at. So this right here will come in as just one string, right? It'll be all the words, and then it'll get split up and trained inside prejudice. And then this is another separate thing we want to look at, but we don't want the username probabilities to get mixed in with the word probabilities, right? Because they're not the same; they don't reflect the same thing. So we want to keep separate the probabilities of words given labels, and the probabilities of usernames given labels, and the probabilities of hostnames given labels. So we're telling it when we say a data length is 3, telling it we're going to give you 3 kind of separate things to train on. So you make a model. You train.
Could you train on 3 and then later kind of expand it? Could you run the whole thing over again?
You could. I would just run the whole thing over again. It's really fast. This is probably one of the fastest algorithms to run. It's like less than a second to do several thousand things in JavaScript. So, I mean, if you're training in like real time from scratch, then I guess that could be a problem. But yeah, it hasn't been a problem for this. So you call train and you give it the 3 different things. So here's we're training on the title. After we take out some characters and change it to lowercase. And we're also training on the username, submitted it, and then the domain name of the link. And then you give it the label, right? Because remember, it's like dog training. You have to tell it to predict something, and then tell it whether it got it right or wrong. So we have to tell it what these things are actually for. And then when you classify stuff, you just give it these 3 things again. We give it a new title from a new post it hasn't seen before, a new username, and a new domain name, and it'll return one of the labels that's most probable for this data. But for some reason, 57 right here, wrong number of arguments. We'll just do but they don't have usernames when they come in from HN archive, so it should just default to unknown. That's good. We should try it from and line greater merge button. Sure, yeah, that's pretty cool. I'm pretty sure I see 3 arguments. We'll just stick a console.log in here and see how many arguments it's expecting. If you guys get bored, just yell at me and go on to the thing and assume this works.
I like it.
Alright, try it again. I don't care what this is like drawing. Expected is 2. Probably messed up the That's like the equivalent of turning it on and off again. Don't care. Yeah, I don't know. This is going to get more painful as time goes on. Obviously, it works sometimes because otherwise I wouldn't be able to do this. Watch this not work too.
Sorry, is it getting the arguments from the label up there where that array was?
So this is just because you have to give it some default stuff when you first make it, but it's actually loading it from, so you can save the model out to JSON and reload it and stuff.
Oh, okay.
This is just so it doesn't yell at me. So when we make a new one, retrain, the length is 4, that makes sense. And now, if we do this, it should load in the model from the disk. I wonder if it's not getting... What? So this is the model on the disk. On disk, it has a train argument that's like 4. When it loads it in, it should read it in. All right. That's weird. Does anyone see anything radically wrong? Aha! That does not look right. Hooray! It's 4. Alright, I swear it works. Don't care about Libya. Yes! Still don't care about Libya. So you can go through and rate these millions and millions and millions of times. I think I rated like 1,000, and that's really way too small. I would want like tens of thousands. Rating 1,000 of these takes a really long time. And so the more data you have in your model, the better your model will be. Right? There's a cool paper that some Microsoft people published in like the early 2000s, and there's all these different machine learning algorithms, and you get like your PhD for coming up with a new one. And when you make a new one, of course you show why all the other ones suck and yours is the best. So everyone is like competing to prove whose algorithm is the best. And these guys just like raised the amount of data they fed into these algorithms to train by a couple orders of magnitude and showed that they all did really amazing if you gave them enough data. They're all pretty much the same. So like the more data, the better, really. So I'll show you some results that I got with this, assuming they don't explode. Yeah, res is cool. No, I don't really care what happens. I don't know. Yeah, so you can imagine rating all these things to build up this model. Now we have this model of all these different words, and whether I like, and usernames and host names, and whether I like posts with those words and usernames and host names or not. Now, oops. New list. So we'll go to the newest tab. So here's where the browser part comes in. We got a slide about this. These are the same thing besides the browser. Yeah. All right. So here's where the browser part comes in. We have this model trained and saved out in JSON, and you can do stuff with that on the server. That's not really too exciting because lots of people do that already, right? You can do that in any programming language. Just send in some data to train the model on the server and update it right on the server. But if we do it in the browser, then we can pull in the model, and I have this little bookmarklet that will automatically hide stuff that I think is lame. And it hid a couple things down there. It's kind of wonky right now, like I said, because the model is kind of bad. But this is cool stuff you can do with it in the browser. So let's go to the front page and see what it hides. Hey, it hit a couple more. So So this is a way for me to curate content by myself. This is a way where I don't have to worry about all the stuff I don't care about, because I just go here and use my little bookmark lid and use the model that I trained to hide stuff that I think is lame. You can imagine expanding this to other sites, right? Like Slashdot has users, and it has links to the stuff that they post about, and it has titles. You could use the same model even. If you wanted to include the text in it, you could expand it a little bit. But you can do this across all kinds of different content stuff. Another cool thing that you can do in the browser is you can send models back and forth, and you can have users train them for you, right? So you can imagine some ginormous data set that has like billions and billions of items that you want to train on. And a really cool way to just do this in a distributed fashion would just send out items to users in the browser, right? Send out things to train them on. And they'll pick a class, and they'll send the data back to a server, right? And update the model centrally. So there's lots of cool things you can do with this in the browser. Yeah?
So what is the model, like for this example, you count up words that are in each category. Would a model get pretty big if there's a lot of...
It could, yeah. We can see... This one is only a couple of 100 kilobytes. But yeah, if you get tons of data, it can get pretty huge. So, I mean, there's like the buzzword big data, right? And you're talking about huge amounts of processing time and disk storage and stuff. This is little data, for sure. But yeah, if you want to do this in real-world examples to get enough data to do good results, it will be kind of big, but I mean, it's still manageable. And there are different, so naive Bayes is just one algorithm. There are other algorithms that use more storage space and less storage space.
And these are usually stored on, so they're stored at the server, or is where's the model stored usually?
Wherever you want it to be. I mean, people that are doing this usually store it in the server. Like Gmail has all kinds of models for their priority inbox thing for you, right? That's stored on their server. And then when new emails come in, they use their model to classify it as high priority or low priority, put a little flag on it. But yeah, I'd say mostly on the server. So, let's see, does anyone have any questions about stuff that we showed or talked about?
I've got a question.
Yeah.
Maybe a couple. One is, so it seems like you took the negative aspect of like determining how to delete things from Hacker News. You're having it delete things that it is pretty certain that you don't like, instead of having it just show you things that it's pretty certain that you do like. So what's like what percentage is that going on, and what would the gray area be? Like if you were to have those results colored green for I like it, red for I don't like it, and yellow for I'm still not sure.
So it either has to pick one or the other, but you can get a probability of how likely that, how sure it is, that label. We go back to math.
Because it would seem like if it's a small data set and it doesn't know, then it would be just as likely to take out something as to put it in.
Yeah, exactly, and that's the problem with having a small data set, is your model does crappy things because it's not very good. So you can just look at this probability. You'll look at the probability of the words given in spam, or in this case liked, and you also look at the probability of the words given not liked, and you'll have to normalize those so they add up to 1. But that'll give you a probability, and you could threshold it so that, say, I only want to see things that it says that I would like with a probability greater than 90% or something, to be really sure. I didn't do that. I just did liked and not liked, just because the model is so small that it...
Well, then how come like half of them didn't disappear?
Because the model is junky, just because it thinks that I would like most of them. I don't know. I mean,
can you get a value return from those libraries between 0 and 1?
Some of them you can. Not this one yet.
Okay.
So it probably didn't disappear enough of them because you haven't given a big enough data set to learn.
Yeah, exactly. And I think it's just biased towards me liking more stuff right now, if that makes sense. Oh. And then you also have the problem of, So part of the reason why a small data set is bad is because you're not covering lots of words, right? There's lots of words in these Hacker News links that aren't in the training set at all. Like I'm sure Priceonomics is in there. So when it sees this, it's like, no idea what the probability of you liking it or not would be given this word or given this URL. I've never seen it before.
So the priors are dominant there.
Yeah.
So what does it do in that case? Just ignore the word completely?
This is where it comes down to a little bit of tuning. You can make it just ignore words that it has never seen before. You can also do things like just calling it equally likely to like or not like it based on that word.
Or, I mean, I guess you can even tweak it and say, if it's a word I haven't seen before, weight it towards I'm not going to like it.
Yeah, exactly. So that's why it's important to know how this stuff works, is because you will have to go in and tweak stuff a lot like that. Yeah, was there another hand?
Yeah, question. So you can say like, I can decrease the probability of, that if I see this word I won't like it. But can you do that on the flip side and say, well, maybe I click these kind of links, so the probability goes up a little, but maybe if I take the time to actually cast a vote on Hacker News, it means I would really like to see more type of those articles.
Yeah, you could add in all kinds of stuff like that. You could imagine...
You just take your
Some
widget.
systematic words.
Yep. Where our little thing go. So in here, you just add another attribute, right? It'd be like, voted up or not. Did I vote this up or not? And if I voted up, then that's a really strong indicator that I like stuff like that. Yeah. So yeah, this is a really simple model. It's like brain dead simple. Any other questions?
So I still have more questions.
Yeah.
So it seems like it would make sense to make, like if you had a large data set, that you'd maybe want to make categories, like be able to automatically learn whether this is related to business or whether it's related to technology, right? And then you'd want to be able to, have lots and lots of these classes. So you have business, technology, health, funny, that you can guess with, and then you would want to have, wouldn't you want to then have like a class that says, I like things if they've already been classed as funny, or if they've already been classed as technology?
So funny is a really hard one for computers to do, but I mean it's hard for
well,
people
just
to do
just
too.
the idea of
sarcasm.
Yeah, but the problem of assigning topics to things is pretty well solved actually. That's an area of natural language processing.
Well,
so you can definitely run stuff through that first. Yeah.
What I mean is how does this scale when we start talking about, like, ultimately we want to decide whether I like it or not, but you can either have like 10,000 attributes, or you could have 20 categories with 4 attributes, right?
So yeah, this is why machine learning is cool, because it's like a never-ending rabbit hole. There's like that's like a PhD right there, like to solve that problem. Well, it might have already been solved. I don't know, but there are definitely things you can do to reduce what's called like feature selection or feature reduction or something. It's where you take your data set and you turn it into some other data set that's easier to learn on. So you can do that. It gets more complicated, of course, but you can definitely do that. So you can think of it as like, you can think of a post on Hacker News as being like a point in some huge like n-dimensional space. And then what you were talking about so the space would be like one dimension for each possible word that could be in the title, plus one dimension for each possible URL and all that kind of stuff. So you have this huge n-dimensional space, and what you're talking about is changing the dimensions of the space to be only like 30 dimensions, where the dimensions are like the amounts of different topics that are in the thing, right? So you could do that, but like I said, it gets kind of crazy. But that's definitely doable. If you're interested in stuff like that, one thing to look at is called topic modeling. That's where you automatically identify topics, as we call them in literature, and they are topics that, like, you think of them in bodies of text. So you could build up this model and then you feed it new data, and it'll tell you the topics in that data. Is there another hand? Yeah.
What kind of projects do you that you can tell us about that you use this in? And can you speak to the usefulness of maybe, reminds me of recommendation engines?
Yeah, so recommendations are machine learning problems. This was like talk-driven development. Like I just did this because I signed up for the talk. So I haven't used this in anything else, but I'm going to keep messing with it. Other things I've used it for are, so one of the things I did on Stack Overflow was I did some natural language processing, and I built up this model of different topics, and then it was basically trying to automatically tag new questions when they come in. I don't know if you guys have used Stack Overflow, but you have to put in tags when you write new questions. So that's a use for it that I've done. But it shows up everywhere. Like recommendation engines are all this kind of stuff. Like advertising to Google AdWords is like tons of machine learning to show you customized ads based on your online profile, and like everything that they know about you is training a model based on what you look like and then recommending you stuff. So it's really useful. Any other questions?
Have you seen the That's What She Said module on GitHub?
I have. That is a triumph of machine learning.
If you guys
give it a sentence and it either says that's what she said or not, based on whether it makes sense.
If you guys want to try it out, you can go into #UTOSC. We have a Qbot bot called Toggle. I can't remember what the command operator is, but if you type TWSS and then something, I wrote a little module that'll tell you whether she said it or not. So.
Wait a minute, are you Stanley?
Yeah.
Oh, I know you online.
66, 67.
Is it?
Yeah. You're going to have to do some fancy.
What's the, I'm not going to do that.
What about doing it over the web, or is it just do the same thing with Java and the web page? If you go to IRC, do you know web page?
I've never played with theirs.
I never have to type this whole thing. Net? Hope so. There's another hand over there. Did you hear him?
Yeah. How do you get the data into the browser? Or how does the browser do that?
So that is where the server comes in, right? The model is just serialized, not serialized. It's just stored in JSON in this model directory. I just have a route. So I have a little express server that all it does is it has this get model route, and all this model does is read it in from the file system and then send it back out to the request. So the bookmark really just hits this URL, gets the model in JSON, and then it has the naive Bayes library on the client side as well, and puts it in from the JSON and gets back on the server. And it doesn't take very long to read it in. It takes a little bit longer. It's like a second to train it, but to read it in, you don't really notice the delay at all. So that's not a problem.
And does it train every time? What is it? How often does it train? Is it cached?
So it's trained. Yeah, it's cached. Like it's trained already. So you don't need to retrain it every time you load it up. And I mean, I say trained. It's just has all the counts, right? So if we do model.json, it just has all these words. I've trained a couple thousand of them. These are the labels for the number 6, which you think is word. I like it twice. I just like it 6 times, right? So this is the trained model. Any other questions?
Why do you dislike 6 so much?
IE6?
Oh,
yeah.
That's legitimate.
It could be it. So, yeah, I'll just say one last thing about this. There's lots of things you can do to your data beforehand to make it nicer. Like you see all these numbers in here, and really seeing the number 7,000, that probably isn't that relevant. So this is a natural language processing thing again called stemming and tokenizing. You can tokenize the strings that come in to just ignore all the numbers basically. And then stemming is where you take things like end and ending and ended and ender. So all these words that have common stems, and you just chop off the suffixes so they all kind of go together, right? Because if you're talking about like intelligent and intelligence and intelligently, if those show up as 3 separate words, then that won't tell you as much. But if you combine all those counts into one word that's like intelligent, then you'll have a little bit more data. It's a little bit less spread out. So that's another thing that I need to do to make this a little better. We're about out of time. So I would love to talk about this stuff more if you guys have questions. But thanks for watching. Really excited about this. Oh, the sponsors, Bluehost and UVU are cool. Don't tell them I forgot. Even though it's recorded.
You didn't forget.
Yeah. Forgot what?
I'll just edit that out of the video.